Hello and welcome to the Age of Gaming. In this episode, I would like to troubleshoot a power supply issue I'm having with one of my TRS-80 Model 1 motherboards. The computer you see on the left, over here, seems to be having a problem with the 5-volt rail. So I figured I would take a working computer and we'll go over the voltages and how to check for them. So let's see if we can get started on this. Let me get over there a little bit more. I'm going to move this, my voltage meter in here so that hopefully we can both see the screen. And then we'll get started. I'm going to start with the TRS-80 User's Guide. It tells you how to check and adjust your power supply. And first thing it tells you to do is to, oh wait, here's a disclaimer here. I have the red lead here plugged into my common because the hook actually works on this one. My black one got broken. So this is the negative lead and I'm using the black as the positive lead, so don't get confused out there. Anyhow, so let's get started. It tells you to connect the common or the negative lead of your digital voltmeter to the right side of the capacitor of C9. C9 is this one right here. And then to check the 12 volt side, we test at the end of, is this one, R18, the large resistor there, the power resistor. Well, it says it's R18. Is that R18? Is that what I said? Yeah, R18. So let's fire this up and start getting some voltage readings. I'm going to go through these really fast, so I won't be giving too much explanation. Hopefully you can see my voltmeter over there. And we're going to power this on. Oops. Red light's on, means we're good. And the first voltage, we're going to check our 12 volt rail over here. And you can see we're getting 12.05. Now the next test they want you to do to test the 5 volt is to put it over here on, what is the name of that one? R4. We get there. Anyhow, so I want to continue on. So that's all they give you in the book. They tell you where the 12 volts is. They tell you where the 5 volts is supposed to be. They don't tell you anything after that. Well, if you read the manual, you'll see these are 2 voltage regulators, and they go into details on how they work, how the reference voltage does this, and the current does that and causes it to do this. I'm not going to go through that. I'm just going to go through the pins. This side is for your 12 volt side and this is for your 5 volt side. So I'm just going to start with Z2 over here, which is a 12 volt side. I'm going to start on pin 12. Let me get my light down in here. I'm going to start on pin 12. Let's see. Right there. And we can see our voltage is about 21.6 on that one. Then I'm going to jump down to pin 6, which is the V reference. Which is right here. That should be around 7 volts. 7.2 volts right there. And we're going to go to pin 2, where I'm getting about 10.59. And pin 4. And 7.1. Pin 5 should be about the same. And then pin 10. Where I'm getting my 12.3 volts right there. And then finally pin 11. I'm getting about 21.05. So again, this is a good board. So these are numbers you should see when you're checking this voltage regulator out here. Now I'm going to go on to Z1, which is, where I'm having problems on the board that isn't working. This is your 5-volt voltage regulator. Now you can adjust the 12 volts here to be more precise, and the same with the 5 volt right here. So let's go through the Z1 real quick. I'm going to start on pin 12, which is there. We're getting about 12 volts right there. And I'm going to go to my reference at pin 6. And my reference is good, 7.2. But this is, now this is where it goes bad on the bad board here, but it's good on this board. Pin 2 should give me about 5.3. Then pin 4 and 5, giving me 5 volts, 4.99. And again, the same with pin 5, 4.98. Then we go to pin 10, and we're getting about, 5.9 volts there. And then pin 11, getting our 12 volts there. Yep. So that's a good Z1, what it should look like. Now I'm also going to do a few extra checks that, may not look at. We're going to try Q6 here. Now what it wants you to do is check the emitter voltage right here. So we're going to check that right there. We're getting 21.6 volts. This is good. And then the collector voltage as well is about 21 volts there. So again, this is a good working machine, so that's good. Now we're going to go to Q4, which is right here. Now I'm going to check that. Have to check that a little bit differently. So I'm going to take this off of here. I'm going to have to lift up the board too to get to the underneath side of it. I'm going to put one lead on the base here, and then one on both sides of the actual transistor. So I'm holding this one. Check the right side here first. And what am I getting? Nothing, because I'm not holding it right.
Oh no.
And 3.9 volts on the right side here. And then on the left side,
Sure.
we're getting about 4.6 volts. Okay, and again, this is a good working. I don't get that on the bad working board, but we'll see that next. And the one other position I want to check, it was Q6 and Q4. Now we're going to check Q3 here, and that's going to be a little fun to try to test as well. I usually like to turn it off first to get this thing hooked on there good, because it doesn't give you much room to work. So I'm clamping onto the emitter there, and I'll go underneath and test at the collector. So let's power it back on. We're back on. Now, raise you up again, right here in the middle. And we're getting about 3.9 volts there. Let me turn it back off. I'll check the other side. I'm moving this.
Well, is this something that you had to dream about or something?
I think I'm on there. Right up again. Now checking the base collector voltage. And we're getting about 3.4 voltages on that side. So 4 voltages on one side and 3.4 on the other. And that's pretty much all the signals that I tested. on the good board. Now let's take a look at the bad board and see what it's doing. Please keep in mind I've switched my leads. I have the red one going to the common and the black one going to the voltage because, I don't know if you can see this, but this clamp works and my black one got broken, so it doesn't work. So we're going to start off by clipping this back on to this side of the large capacitor, and we'll put this on voltage. Hopefully you can see that. And we'll start by doing the check that the book tells us to do and see if we have our 12 volts here. Oh, helps turn the thing on. And there we do have our 12 volts on the bad board here. Now, here's where we run into a problem when we check the 5 volt side on, what is this, R4. And here we're only getting 2.1 volts. So you can see we have a problem on the 5 volt side right there. But I'm going to go ahead and go through all the voltage regulators and through the 3 different transistors here. So let's get through that as quickly as possible. Let's see, we're going to check out Z2, which is the 12 volt side. We're going to start with pin 12. Get my light down here. Pin 12 is right there, and what do we have? I think we have 20 volts, 21 volts, that's correct. And our voltage reference should be on pin 6 here. Should be around 7 volts. Yeah, got 7 volts there. And again, this voltage regulator is our 12 volt side, which we know is working. So, but I'm going to go ahead to pin 2. We have 11.2 volts. And then we're going to go to pin 4 and 5, which is pretty close to our reference voltage. No, oh, 4 and 5, my fault. 4, 7, and 5, 7. Okay, now we're going to go over here to pin 10. We have about 13 volts there, 13.1. And finally, we're going to go to pin 11, where we have 20.2 volts. Okay, well, we know the 12 volt side is pretty good. Now let's go to the problem side. This is our 5 volt voltage regulator IC, which is Z1, and we're going to check out again pin 12. Well, we have about 12 volts, which is good. And then we're going to check our reference on pin 6, around 7 volts, which is correct. And here's where we run into problems. Pin 2 gives us 2.4 volts. Pin 4 and 5 are giving us 2 volts. Here, pin 5, 3.9 volts. And then, of course, pin 10, also a bad reading, 2.9 volts. And then pin 11, giving us 11.9, which is pretty close to correct there, too. So now let's go ahead and take a look at Q6, Q4, and Q3. Start with Q6 here and check the emitter voltage, which is 20.9, 21, that's correct. Collector voltage here, 20.3, that's great there too. And now we're going to start checking Q4 and Q3, and that's where we run into problems again on the 5 volt side. So again, I'm going to be putting my negative lead right here and then testing on the other side. So let me lift this up. Move my lead down here and we'll check the right side of this one first. And we're getting 11.9 volts. Or, hang on, it's back on here. We shouldn't actually be getting anything. We're getting about 30 millivolts, 29 millivolts. We'll check the other side. And here we're getting 9.2 volts when we should be getting about 5. So way off on Q4 here. And now let's give the Q3 a try. Again, let me power this off. So I can hook my lead up to the emitter side first. And we'll power it back on. Find out what we have here on the emitter side, emitter to collector. About 26, 27 millivolts, 28 millivolts there. Put that down, power off again. And try the other side. Power back on. And check this time from the base to the collector. And here we're getting 0.7 volts. So as you can see, on Q3 we're really not getting anything good. Q4 we had 9 volts on one side and 30 millivolts on the other side. Again, no good. So those would be the two chips that I'm probably going to replace and see if we can't get this board working again. Anyhow, I hope you learned something. I was able to give you the good voltages from the good volt to the good board, and then show you what was going on this bad working board and see if we can't fix it by replacing Q4 and Q3. Anyhow, thanks for watching. Have a good day.